Have you ever noticed that if you take the derivative of the formula for the area of a circle with respect to the radius, you get the formula for the circumference of the circle? Is this just a coincidence? It doesn't look like a coincidence, because when you take the derivative of the formula for the volume of a sphere, you get the formula for the surface of a sphere. The reason for this is the very definition of what a derivative is. And at an intuitive level, it can be explained from the fact that a derivative is what we call an instantaneous rate of change. In this particular case, a derivative is telling you what happens to the area of a circle of radius r when I change that radius by an infinitesimal amount. If I change the radius by h, I'm going to have an increment in the area by this orange region. And then when I change my radius from r to r plus h and let that h be smaller and smaller and smaller, what happens is that the increment at the limit, at the instantaneous rate, is reduced to an increment that is equal to the circumference of the circle. And similarly, when you have a sphere of radius r and then you change r for r plus h and let that h go to 0, the instantaneous rate of change becomes just the surface of the sphere. We can of course use the limit definition of derivative to see that this actually happens, that the derivative of the area will be the circumference of the circle, because when you simplify that expression, the difference in areas divided by h, and then let h go to 0, you do get 2 pi r. Finally, a question for you. If I have a square of side length x, the area is x squared. And if I take the derivative of that, I get 2x. However, the perimeter of the square is 4x. So what went wrong here? Why is it that the derivative of the area is not equal to the perimeter?